talking about kinematics, one thing we want to remember, which is probably the most important thing to remember, especially for projectile motion. So for projectile motion, one thing we want to do is to make sure we separate our x and y variables. And we want to make sure that we use, anytime we are looking for time or height, we're going to use our y variables. And anytime we're looking for range, horizontal range, we will use our x variables. Okay, and just some general tips that apply to any kinematics problem. It could be helpful to draw a picture, especially if we are stuck. And also, if we are stuck, it's important to write our knowns and unknowns. To the first example, and here we have what would normally be a part 2 question, maybe split up into A and B, definitely 2 parts, or it could be give you the scenario and then ask you a series of multiple choice questions about this problem. So we have a baseball thrown horizontally off of a cliff with a velocity of 40 meters per second. Anytime we see the word horizontally, we want to make note of it, because if it were thrown at an angle or it were dropped from rest, it would really impact the way that we analyze this problem. So how long is the baseball in the air for? We're looking for time. And how far does it travel in the x direction? This is also known as the range or the distance in the x direction. So like I said earlier, one of the first things that we should do is draw a picture. So if I draw this scenario, here's my cliff, a level ground. We have the baseball, which is thrown horizontally with the speed of 40 meters per second. The dy, or the height, is 50 meters, which would be this height here. And just a quick review, throughout this height, this object only has gravity acting on it, and this is a force, and it's going to follow a parabolic path. And here is the distance in the x direction, or the range, and that is the second thing we are looking for. Now, since it does not have an initial velocity in the y direction, it's thrown horizontally. So one of the things that means is the initial velocity in the y direction is 0 meters per second. So we think back to the tips, it's very important to separate our x and y variables. So when we're looking for the time, we only want to use the y variables. And when we have something thrown horizontally, we're going to use our free fall formula, which is d equals VIT plus 1/2 AT squared. And if we want to get really specific, I'll do my best to use this marker to write, but we can make all of these variables y specific. The acceleration in the y direction, the initial velocity in the y direction, and the distance in the y direction. Now, we don't want to mix anything in the x in there. So when we see this, a common mistake is to plug this 40 meters per second in there, which we cannot do. So now, if we're starting here, we're ending up 50 meters below where we're starting. So our distance traveled in the y direction, when we take into account displacement is a vector, is going to be negative 50 meters. We're thrown horizontally, so this is going to be 0 meters per second. We're looking for time. This whole term will cancel. Plus 1/2, I'm running out of room here, and acceleration due to gravity, we'll assume this problem is on Earth, is negative 9.81 meters per second squared times t squared. So let me clean this up. So since this term canceled, we have negative 50. I'll do this all in one step. In my calculator, I'll multiply that 1/2 and the 9.81. So I get 4.905, but remember it is negative, so negative 4.905 times t squared. Now I can divide both sides by negative 4.905. Now I know I would make a mistake if I ended up with a negative in this step here. So when I do 50 divided by 4.905, I'm going to end up with a positive, which is 10.1. It's going to be seconds squared equals t squared. If I had a negative in this step, I would know that I made a mistake because I cannot have a negative time. That is impossible. So we would take the square root of this answer, and we get that this baseball is in the air for approximately 3.2 seconds. And if we think back to earlier in the year, we can recall that x velocity for a projectile is constant. And if we were to explain on a part 2, why is it constant? It's because there's no force in the x direction. Right? Gravity only acts in the y direction. Therefore, it's going to be constant velocity. Whenever we have a constant velocity, we can use v equals d over t. But remember, we want to stay specific by separating our x and y variables. We know the horizontal velocity, 40 meters per second. We're looking for how far this travels, and it's in the air for approximately 3.2 seconds. Cross multiply, so I multiply 40 meters per second by 3.2 seconds, and I get 128 meters as my horizontal range.